We'll just wait 1 minute to make sure that we are in fact live. Don't see us yet on YouTube, so let's just take a second and see.
It looks like we just went live.
All right, well, we did it. Okay, cool. All right, thank you all for being here today. We are going to be doing some Ethereum trivia. We were in Toronto, some of our team last week, to do some of this trivia at the Futurist conference. And so it was really fun. We had a good time doing it, and I think that everyone who is there also did. So we're going to do a follow-up, some of the same questions, some are different. And what we're going to do is go through, we'll read the question. If you're watching this, I'll give you a second to answer in your head. Feel free to add it to the YouTube or any of the other chats. And then we will explain what the answer is, why it is, and we'll all jump in and give some more information. But first, let's introduce ourselves. I'm Jessica Levesque. I'm the Executive Director at C4. And I love Ethereum. I have my Ethereum shirt on today. I'm pumped to be here. So why don't we go around and introduce ourselves? Cheyenne, do you want to start since you're our chair?
Sure. So I'm Cheyenne, CTO at Ether Capital and the chair at the CEP or Certified Ethereum Profession Committee. Happy to be here. Josh.
I'm Josh McDougall. I'm a co-founder of C4. I sit proudly on the Certified Ethereum Professional Board Committee, and I'm the president of Slow Ninja. Hannah?
Hey everyone, I am also a proud member of the CEP committee, and I also am the VP of events at a company called Serotonin. Sonal.
Hi everybody, my name is Sonal, and I just recently joined the CEP committee and I'm super excited. I learned about it in another work group that Jessica and I lead together that is also around spreading knowledge around Ethereum. In my day job, I lead operations at Consensus Mesh for our research and development unit, where we do research and development around uses of Ethereum technology. Thank you.
Awesome. Yeah, and this is Sonal's first live stream with us. So thank you for joining us, Sonal, and everyone else. We personally think they're super fun, so hopefully you enjoy being on it. And I know that the people that watch generally think that they're fun and learn a lot too. So let's get into Ethereum trivia so we can all geek out over something we all love, which is Ethereum, all things Ethereum. So let's start with the first question. I'm trying to look at who is going to take this one to start. Let's see, is it
this one's on me.
All right, hit it.
All right, so question one, what problem did the blockchain solve, or did blockchains in general solve? The first blockchain being Bitcoin, with made by Satoshi Nakamoto. So what did the problem solve, or what did Bitcoin solve? Decentralized consensus, public key cryptography, spam prevention, or online payments? Might feel like quite a few of these. There's one key answer here. All right, you've had your time. The answer, of course, being decentralized consensus. So of course, some of these are applications that we could now use with that problem. We could create online payments thanks to solving decentralized consensus. But ultimately, the problem that a blockchain solves is the ability for all of us to agree on something across the internet. Of course, we have lots of technology for disagreeing with each other over the internet, such as Twitter and Facebook. But blockchains allow us to all agree on something.
Yeah, I think one of the cool things is, like, when we think about Bitcoin, or when, blockchain started, we kind of forget that there was such a lead up to it. There was so much technology. There's all this talk like, oh, this brand new invention, but it's basically a bunch of other inventions that came together to make decentralized consensus possible. And actually, we're going to be releasing a blog article soon on the Byzantine generals problem, which talks exactly about what this problem is from a game theoretical perspective. Did anyone else want to add anything? All right, we can head into the next question then. All right, Hannah.
Cool. All right. Who is Satoshi Nakamoto? A famous breakdancer? Maybe. The pseudonymous individuals who invented Bitcoin. Barbie's first love interest. Aww. Or the inventor of the first computer. Answer
It was
is
Barbie's first love interest, right? I'm just going to throw that out there.
Oh,
Ken?
definitely. Gotta be. Great. I think we're ready for the answer. It is B. Satoshi Nakamoto is the pseudonymous individual or individuals, we don't know, who invented Bitcoin.
I think it's so cool that we still don't know. Like, I think it's fascinating to have this be something that is still an unknown in a world where we so want clear facts. And like with computer coding, well, not that I'm a programmer, but like to be able to see exactly what it is, but we don't know this person. Are there other technologies, I'm trying to think, that are like this, where like they're something no one knows who created it, but it's something everyone is kind of trying to figure out?
Life on Earth.
I mean,
Did you just say life?
Yeah, life on Earth.
Well, that's like the best answer.
the wheel.
That is
good.
great.
think
Yeah, be
the
very skeptical of anyone who does claim to be Satoshi.
I think the
That's
beautiful part about the fact that we don't know who it is that who it is really doesn't matter at this point. We don't care about their intentions. We don't care about their motivations for creating this. None of that really matters. Now the technology is here, and we can all do with it as we each see fit.
Yeah, I love that. Like, it doesn't matter. That's who it is, isn't, or who they are, isn't the point. It still exists regardless of that.
Someone in the chat says that like the NSA knows, but I doubt it.
Okay, let's head to the next question. I think this one is also you, Hannah.
All right. What year was the Ethereum yellow paper published? Was it A, 2010, B, 2013, C, 2015, or D, 2017? And our answer is...
I just want to give some time to people. So there's like 6 or 7 people on YouTube watching this. If they have answer, do we have like any t-shirts, free CEP or something to give?
Yeah,
us
we'll be
rewards?
giving out
Yeah.
CEP codes for sure. And also, I didn't think about the t-shirts, but if anyone is interested in having one and wants to rep C4 when you go out and about, let us know, because I don't know, I think they're cool. Hannah thinks they're cool. She's wearing one. She can't keep away from it. One of the things I think is interesting is like with the dates, like how important are the dates and why are they important? Like, why does it matter when the yellow paper was published, which is different from the white paper, which we'll explain in a little bit. But I don't know, we've decided, and I think it'd be an interesting question for the committee, we decided to put the timeline in there. And like for our CBP course, we talk a lot about the timeline, but does anyone have thoughts on why it matters, like where things started from in the context of where we are now?
Well, I think the history is always important to know. I mean, especially in a space that moves at an incredible rate. It's good for us to be able to look back and know when certain things started or were published, or when a piece of tech kind of came into the sphere of know amongst the crazy crypto community.
Yeah, and exactly that point, like there was no way to have, like if you couldn't have like Ethereum before Bitcoin, because Bitcoin is one of the simplest blockchains, even though it's still like hard to explain that to like a lot of people, but Ethereum is way more complicated, and it's building on top of a proof of work that was Bitcoin proved that it works. Similarly, like right now, we can discuss proof of stake could not have existed before proof of work. There's a lot of these part of the history that you need to know. And also one thing that I realized, a lot of these concepts actually takes time to get soaked into the brain. Like even mining, like it takes some time to understand, and then takes some other time to like realize the worth of it.
Like a lot of time, depending especially on your prior understanding. Like when I fell down the crypto rabbit hole, I came from an English like teaching background, and it was completely out of left field. And the amount of stuff I had to learn was just like, it was like one like mind explosion after another. But I love learning, and it was actually really cool to find out about these things and see like this whole world I didn't know existed, basically. I also think it's important to point out that the Ethereum white paper was published first, and then the yellow paper after. So Vitalik Buterin published the white paper, and then afterwards, Gavin Wood explained it more. I think it's more in depth and then more like simple. Is that the way, like, is an easier way for people to understand it as well? I don't know exactly if I'm saying this correctly. Cheyenne, you've probably like read all of them and knew what every single thing said in them, unlike me. So what is your perspective on that?
So white paper was basically a general idea as like, we have Bitcoin that's extended to like be a word computer, add more functionality to it. And a lot of paragraphs or ideas there were kind of loosely defined as like, this is the idea, let's try to do it. I think we can hint as like white paper was in 2013. A bit after, when the yellow paper came out, was basically the idea of yellow paper is a specification to the details of like how things should be implemented, or the math behind some of the aspects of it. And I can't say I understand everything in yellow paper. There are like some parts about the memory modules and like how it should work that is like beyond me, or like it's actually gets into the math of it. So the yellow paper is still today relevant for using like how the gas should be estimated, or like a lot of other aspects. And it's kind of looked a lot of time as like the Bitcoin white paper as like, once Satoshi said this and we have to like stick with it. Like yellow paper is almost similar to that because it is a specification. But a lot are being changed because of the EIP 1559, like proof of stake, and how like Ethereum is basically evolving. I think we can go to the answer soon.
Oh yeah, let's go to the answer, and then I think we should say what EIP 1559 is. Okay.
The answer is C, 2015.
So real quick, since this is an educational trivia, Cheyenne just mentioned EIP 1559, and EIPs are Ethereum improvement proposals, and it's something that that those who are interested in it vote, miners, on. I'm explaining this terribly, on consensus. Can someone explain this better? I feel like that was the worst explanation of all time on what an EIP was. No, should I try again? Okay. In Ethereum improvement proposal, there are different people that propose things on GitHub that want to make changes to the network. And so 1559, also known as the London fork, is something that changed how fees and how transactions work within the network. Is that correct and better said?
Yeah, so that's basically how the gas estimation works and how supply works. And the idea mainly is to basically burn some ETH every time, and the way it's calculated, it more adjusts the gas price, so there's no spikes. And then, because before there was, everyone would calculate the gas estimated from the previous block, and that would result in if there's an NFT drop that the gas is going high, all the wallets would make it even go higher because of the kind of like a short history before that. EIP 59 started having a more standard on how the gas spike should happen, and also burning ETH, which adds value to the rest of the ETH holders. But I think we have like one webinar, one of the episodes that we talked about more details of like EIP 1559.
Oh, do we? I forgot. Okay, cool. Well, let's head on to the next one then. Okay.
Oh, I think that's me. So when was the Ethereum Genesis block mined? And by Genesis block, we mean the first ever block on the Ethereum blockchain that we know today. as a matter of fact, the same block on Ethereum Classic, Ethereum, and any future forks of Ethereum would be the same block that we're talking about now. So was it January 3rd, 2009? That sounds familiar. July 30th, 2012, July 30th, 2015, or August 29th, 2018.
I feel like now we know we need to do music between questions
Yeah.
next time. If anyone wants me to start singing, you'll probably like never want to hear anything again because I'm so tone deaf.
Always room for improvement.
Yeah, we can also bear in one of the wrong answers. Like, anyone knows what January 3rd, 2009 is?
There was a
Someone
different
put-
Genesis block that day, I believe.
There was indeed.
Well, which one was this Genesis block? I think, well, we've got someone guessing in the yeah.
Yep.
Yeah, 2015. So yeah.
Can we just
July 15th.
stop for a moment and appreciate that was mentioned earlier, I believe it was Hannah saying how fast things move in this space. In 2015, an outline was written to say, yeah, we think we should build this. And by July 30th, the Genesis block happened. That's pretty insane as far
that's
as
phenomenal.
just publishing a quick little world-changing blockchain. Well done. Kudos to the team behind it.
Yeah, it's amazing. All right. I'm going to take this one. What is a cryptographic hash? A signature created from a private key. B, a digest of data. C, a delicious mix of potatoes, onions, cheese, and coins fried to perfection. Or D, a reversible form of encryption. And if everyone doesn't say C and then also make me this dish minus the coins, I will be very disappointed. Sounds delicious.
Making me hungry.
I know. Oh, there's more. Like, you can tell that everyone enjoys food because a lot of the answers that we all put together have to do with food. We couldn't help it. Don't make trivia when you're hungry.
So instead of music, we should just have like something sizzling on a stovetop, or maybe the
You
roar of a
eating,
barbecue.
Josh?
Oh, some yeah, just some crunching sounds. Perfect.
Yeah. People love that. All right. So it is not a signature created from a private key. It is unfortunately not the delicious treat of food, and it is not a reversible form of encryption. In fact, it is the opposite of a reversible form of encryption. So when we talk about what a cryptographic hash is, this is actually something I mentioned on one of our social posts, is that once this happens, it can't unhappen, basically. So a cryptographic hash function is basically a mathematical algorithm. So something goes through a process and it can no longer be reversed and go back to what it was before. And so the example that we put on socials was, and I'm stealing this from the chairman of the board, Michael Perklin, because I love this example. If you have a piece of bread and you put it in the toaster, it's going through this encryption algorithm. When it comes out, it's toast. You can't untoast bread. Once it is, that is its new form. And so it turns into this digest of data. It turns into something different that comes from something else, but can no longer go back. Anything else anyone wants to add about that? Other than that also being a food reference, I just noticed.
Yeah, I should have had lunch before this.
I know. Same. All right, cool. Let's head to the next question. Is anyone assigned to this one?
It's Josh.
Josh, yeah.
What? I'm Josh. It's crazy. Okay. In Ethereum, a private key is used to A, authorize transactions, B, connect to the network, C, reverse transactions, or D, hide your secret stash of candy from your coworkers. Now, if candy is some sort of token, that might change this answer. So if we're back to the food wars of like 2020 DeFi, The answer might be slightly different.
I was actually just thinking that also, like, what if your private key holds the funds that access your candy supply?
Oh,
That was the whole idea about Slockit and all the unlocking doors with your private key, right? But I don't think they thought about the candy use case.
I don't
okay, well,
know.
clearly
I don't
got a
know
good
about
project
that,
to start.
Cheyenne. Something new for me to research and look into, I guess. It's always something new. It's possible
Yeah,
to keep
so
up there.
yeah, like Slockit was the project that was working on a lock that unlocks with, let's say, a Ethereum transaction. But they had an interesting pivot. They switched to make the DAO. So Slockit team was the team that created the DAO, which resulted in basically where we are now. Like a lot of things, like Ethereum Classic, knowing reentrancy attack, a lot of security was important. That all those aspects came from the DAO and also the Slockit team.
Again, knowing history is always fun and important. Now, of course, going on to the answer of this question here, in Ethereum, a private key is used to, in fact, authorize transactions. You do not need a private key to connect to the network. Anyone can connect to the network. You do not need a private key to reverse transactions because you cannot reverse transactions. And as far as your secret stash of candy, you might be hiding that behind a treasure map encrypted with your private key, but that's kind of not really in the CEP's scope. So of course, in order to create a transaction, you create the details of that transaction, be it sending ETH or executing a smart contract, and then you sign the details of that transaction with your private key to authorize it.
That was a really good explanation. All right, Sonal?
Yes, question 7. An Ethereum address will always start with a 0x. A, true, or B, false?
I feel like this is such an interesting way to look at it because like obviously once you know whether or not this is true, and we'll explain it, there are different types of starts to different crypto addresses, and it's interesting to think of how that is and like what that defines, which we'll go into after we talk about whether or not this is true that it starts with the 0x or not, and how you can identify what blockchain based on the address.
Yes, so the answer is true. All Ethereum addresses have a length of 40 hexadecimal characters following the 0x.
It's interesting too, like when something else is on the Ethereum blockchain, but it's not Ether. Can anyone explain what that, anyone else, like what that looks like on, like when you're actually looking at it, how you can identify what chain something is on based on what it starts with? Anyone want to jump in?
Sure. So a lot of them also depends on the history, because like even the Bitcoin addresses were like starting with 1, now with like BIP32, it starts with like B, like a small b. There's like starting with 3 was like multi-sig transactions, and now all the SegWit transactions are like, oh, this is a lot of Bitcoin for the CEP call. But on Bitcoin, basically all the addresses start with 0x. A lot of like basically 0x means that it's a hex at the end of the day. But like it starts with that. There's like, they call it a camel case, that like there are some characters like in capital and some lowercase, mainly because that's a checksum. You can use all lowercase. Also, it's valid. But if you use like a full-on address, there's actually a checksum, which means it detects errors in the typing of the address. One issue that started with a lot of these EVM or Ethereum virtual machine forks, where they kept the same address, the keeps format like Tron, Binance Chain, all those, and it created a lot of confusion between like all the users, basically because they would withdraw from their own address, but they were not controlling the same address on the other chain. But technically they were controlling the same address because they had the private key, but there is a whole wallet, like client and all those things around it to be able to like access it. But we've seen with like exchanges, people would deposit in the wrong chain or other things, which at this point of my life and development in this space, I feel like that was a developer's like not being thinking future forward and understanding the user experiences that they're going through. But I mean, we passed the momentum part and it's there now. A lot of other chains start with ZLX.
Yeah, I think there was an assumption that eventually something more human readable would wrap this information. So you would see like, you know, Ethereum and then some gobbledygook or something. That way, when you looked at it, you saw, okay, I know what this is. And that just never formed. And instead, these kind of like raw details just became lore and fact. And now when you see OX, you know it's probably Ethereum, but it might be all these different layers that you know kind of talk the Ethereum language or talk the EVM or use a similar core. You can blame a lot of things on hindsight being so simple to look back and say, well, this doesn't make sense. But yeah, good intentions on that.
All right, so that's me. It is always possible to reverse a transaction by selecting undo in your Ethereum wallet or Ethereum client. True or false? So some info on this. The concept of undo was really foreign in the blockchain world. And there were like some ideas kind of hinting back to Bitcoin that they started something called RBF, replaced by fee, that the concept of undo or like replacing a transaction started happening. When on Ethereum basically didn't exist till I believe MetaMask was one of the first that implemented the option. But is this a possible thing to reverse a transaction? That's the tricky question. I feel like also the delay with the YouTube video kind of like makes us wait longer for people to answer, because I just saw an answer about the previous question.
Yeah, there is a delay, even though we tried to get rid of it, there just still is one of the joys of technology. It's amazing when you think of like all these like just cool things we're talking about, and then it's like, yeah, but we can't fix the delay. It's like all these cool, amazing things people are doing, and then the small little like issues still with technology.
Someone's asking, oh my God, where is the undo button? So the answer to this is false. So we still have the undo button, but like, what does it do? So the idea was similar, going to back to that RBF, which is easier to explain, was you could send Bitcoin transactions with just a flag that this might be replaced with a higher paid fee or fee paying transaction that would replace that. And Protocol had that implemented, I believe in 2014 or 15. And on Ethereum, it doesn't exist like that, but each transaction has a nonce, meaning that every transaction you're sending out has an incremental nonce. Like the first transaction is 0, 1, 2, 3, it goes on. And the way basically MetaMask implemented that on some other wallets is, let's say you send a transaction with a nonce 10 and you're waiting for it to confirm. Suddenly you decide before it's confirmed, like if it's confirmed, it's gone, it's done. But before it's confirmed, you can send a transaction with the same nonce and pay a bit higher fees to replace that. Like miners would go for the higher fee paying transaction. So usually the way it works is just a transaction to yourself. So MetaMask sends a transaction with the same nonce as the transaction you're undoing and is not confirmed to yourself. So you end up paying gas. It's not undo in that sense. You just pay the money to yourself. And that's how undo is implemented, but it doesn't reverse the transaction. Should we go to next, or do you want to add anything?
I don't see any other questions on this in the chat. Did anyone else want to jump in? I think that was a great explanation. Okay, let's see. What is the next one?
This is
think-
my question.
I don't know.
Yes. Which key is used to sign transactions? A, the public key, B, keyline pi, C, private key, or D, the skeleton key? And I'll give everybody a few to let us know in chat or think about it.
Or like go to the store to buy the ingredients for pie, whatever you want to
Yes.
do while you're waiting.
All right. So the answer is C, a private key. The private key is used to sign transactions and prove ownership of the blockchain address. So a transaction is encrypted using a public key, and it can only be decrypted by the accompanying private key, similar to a password that you do not want to share with anybody else.
Yeah, I'm glad you brought that up, Sonal. Private key has the word private in it for a reason. You want to keep it to yourself for sure, not share it with anyone. And do research, learn from experts on how to make sure that you are keeping your key private. And actually, Jameson Lopp, he's on our CCSS committee. He just posted something today about the best devices for securing a private key. He put it on Twitter. I thought it was pretty interesting. If you are interested in checking it out, those are about Bitcoin, but I think that most of what he put works for any private key.
Usually they have the seed phrase in there, right? And I believe I know the blog post. It's so there is this concept of being resilient to any even natural disaster. So I think that's the post that there is it hammered on the piece of metal, and if it's recoverable. I don't think a lot of users need to go that extent unless you're a crypto millionaire and you just need to keep it their backup. But the hardware wallet should be good and a backup in a safe place. But yeah, that's a hobby too, right?
Yeah, it depends how much you have and how much what you have means to you. You know, different values mean different to different people, for sure.
Yeah, just something to add. So I have it's not really that visible, but here is a small butterfly lab ASIC device. I think I talked to Josh about this, but I bought this for 3.5 Bitcoin. It was like $300 back then. And I also mined around $50 worth of some random coin, and it was burnt. There's a hole on the board right now. And I keep it there just to realize that basically I spent 3.5 Bitcoin, which a few months ago was $200,000 on the piece of hardware, and it's just sitting there right now. So
yeah,
it's a lovely.
Mm-hmm. All right, should we get to the next question?
Sure, I think this one's mine. So what is a stable coin? Is it A, a token without inflation, B, a token pegged to another asset, C, a token with a fixed price, D, a token that helps the stability of the network? And maybe while we're waiting for people to jump in with answers before we reveal, we could talk a little bit about types of stable coins, or maybe how many types there are.
Mm-hmm. Yeah, and I think the answers on this one we might want to explain a little bit. There's kind of like a caveat. I think, Josh, last time we talked about this, you did that part of it, so maybe you want to jump in after. But yeah, there are a lot of, how many stable coins are there?
Ooh,
1 billion?
there are certainly
Yesterday or
quite a
today?
few. I think there are 4 main types as to how they're defined, but I don't know about just how many are out there.
I don't know either. This is what we're saying. It's hard to keep up with everything because there's always something new happening.
Definitely. I feel
Yeah.
like we've given enough time.
Yeah. So an example of a stable coin would be USDC, for example.
Yeah, we have I can't really read the username, but they said B is the answer, which is
Correct. Great job.
Mm-hmm. It is. Josh, do you want to explain well, Hannah, I don't know if you want to go on, but Josh, didn't you explain a little bit when we talked about this last, the token with a fixed price and how it relates to that? Is that this question?
I don't think that was me, but I mean, I would say possibly A, B, and C. Really, it's just the question was stablecoins. Stable against what? It's a coin that's attempting to be stable. And I mean, B is certainly correct in that it's, if USDC is the example, it's pegged to USDC. But there's other attempts at creating stability in the price of a coin as well.
Right. So if it's pegged, if a coin is pegged to like USD, it isn't without inflation because USD suffers whatever you want to call it from inflation. So even you can peg it to another asset, but unless that asset doesn't have inflation, then it doesn't count for that. Same thing with the token with a fixed price. All right, cool. All right, I think this one is me. Yep. All right, why is the EVM, the Ethereum virtual machine, described as quasi-Turing complete? A, the computational model is restricted by the block gas limit. B, some instructions are missing from the EVM bytecode. C, smart contracts are immutable, hence not fully Turing complete. D, quantum computers are the only full Turing complete devices. So while we're waiting for the answer and for people to think on this a little bit, let's explain where the word Turing comes from and why it's capitalized. So Turing comes from computer scientist Alan Turing, and I think that Turing completeness was beginning to be discussed in like 1936, something like that. And so the idea of it is, well, I guess I have to wait for the answer in order to explain what it is fully. So I'll wait a second.
So we have Johnson that says the answer is A. Should I go for the answer?
Sure. I mean, he's right. Okay, so Turing completeness means that something that's on a computer can run forever, that something can be imitated, it can run forever. But with Ethereum, if you don't have enough gas in a transaction, it will stop. So there's a limit to the Turing completeness because of the block gas limit. Does anyone want to jump in and explain that from a more technical perspective?
Yeah, I mean, it's pretty accurate already, but the key factor is if you give something that's Turing complete long enough to run, it can theoretically complete any puzzle that you give it. But sometimes it needs an infinite amount of time, or back then, an infinite amount of tape. You need to be able to feed it with enough constant, tape in order for it to actually complete this computation and complete the problem. In this case, a Ethereum smart contract can complete any task. But the problem is there's not enough time for it to complete every task because they have to limit the amount of computations each smart contract gets within a block. So theoretically, the Ethereum network could complete any puzzle or any computational problem, but time and resources is the limiting factor for it.
Yeah, thank you. That was a great follow-up. Appreciate it.
So that's me. The consensus mechanism was the first choice of early Ethereum architects. Proof of work, or proof of stake, C, proof of authority, and D, proof of transaction.
I'll just say I love this question, and it goes back to our discussion of history in the space and why history can be important. I'm gently giving away the answer, but I think it's still tricky enough and fascinating.
I was just thinking it is absolutely fascinating to think of. And I think this is something that not everyone knows. Like, I think this is a pretty good question for even people who have a good understanding or feel like they're somewhat familiar with Ethereum, that there was something that was in place intentionally for a long time. Or that would be in place if possible, and that the decision to do, I'm giving away the answer. I'll stop talking. Put myself on mute. Cheyenne.
Yeah, Johnson has the right answer again. That's B, and saying that the merge has always been coming, which I like. But yeah, so it was supposed to be proof of stake early on. The technology wasn't there. So Ethereum started with proof of work. And again, in 2018, there was this, basically the Serenity fork was supposed to happen to be like, again, move to proof of stake, but it was so complicated that it was almost impossible to make that work. So now the whole design will like simplified, and hopefully we're gonna have the merge, see the merge. And apparently we spelled authority wrong, so that must be the wrong answer.
I just saw that. I didn't even notice when I was looking at it now either.
Yeah, and there's interesting things. So like a lot of like some random trivia points here. So Binance chain basically has like 21 nodes or validators running, and they call themselves, like they called early on, I don't know, like I haven't followed the development tech in the last year or so, but they were called proof of delegated authority, meaning that those 21 nodes have the authority to basically approve the transactions. Apparently now use a proof of work, but that was one of the things. And I don't know what proof of transaction is, but there are so many of these other proofs, like proof of space or proof of time. There's all these aspects that like has been played around, and it's interesting to see like if we see more blockchains using these exotic proofs.
Yeah, it is. And we're going to do another question. And then after that, we've got a couple more questions about the proof of work, proof of stake, what that looks like, what the merge is. And we'll discuss that for a little bit, and then refer you to where you can learn more about the merge as well.
Cool.
Right,
so
sure.
This is also me. This is a timely question. We can have some interesting discussions around it, but let's see. So what are the characteristics of Ethereum blockchain? Choose all that apply. It's open, it's censorship resistant, it is decentralized, it is energy efficient, and it is artistic. Just before getting to that, Mo Love is asking, so Ethereum original developers created the proof of stake rather than following Bitcoin proof of work, or was proof of stake developed by others? So the concept of proof of stake was not necessarily done by developers, by the Ethereum developers, but that was like something that they focused on to implement. And I know there are some other blockchains that started using proof of stake way earlier than Ethereum. Josh, do you have something to add on that, or like on proof of stake original?
Yeah, just the initial plan when developing Ethereum was to use proof of stake, because they just felt like they could actually get a better throughput with it eventually. They felt it was, kind of unique and something that needed to be explored more. And also they were worried at the time there was frequently issues where if you were competing with proof of work against the Bitcoin network, so if you had two networks that both had proof of work as their consensus mechanism, one kind of frequent attack on smaller networks was to move, a fraction of the Bitcoin hashing power over to that smaller network, spike up the difficulty, and I'm using lots of fun terms here that tend to be in many of our certifications. So if you don't know what difficulty is, I highly recommend looking that up. But spike up the difficulty and then move the hashing power back over to Bitcoin, leaving that network almost paralyzed and stuck, because now it was too hard to actually mine on it. and the people left on the network couldn't progress it forward. So there was frequent attacks on smaller networks that shared proof of work mechanisms. So they knew that they didn't want to use the exact proof of work mechanism that Bitcoin was using. So instead, there was a number of reasons why they wanted to try proof of stake and thought that was the better way forward, but also they didn't want to use proof of work for specific reasons too. They ended up using proof of work, but a custom one that prevented that, migrating large amounts of hashing power over that similar attack. But ultimately, it was, or certainly other networks have tried to develop proof of stake mechanisms over the years. And it's a small industry, there's a handful of people doing very hardcore research in such mechanisms. So I think it's unfair to say that Ethereum developers were the only ones working on Ethereum proof of stake when it was, a kind of a family and community affair. Lots of different networks and projects have explored the benefits of different procedures. There's so many people, so many smart people working on proof of stake. It hasn't just been one or two Ethereum devs that have kind of led the charge here. So it's tough to say who actually coined the best use of the technology, but we'll see when it emerges as well.
Yeah, something that also in the chat Johnson said is something in hindsight, we realized that with proof of stake, you don't necessarily need to sell your coins, so you accumulate more and more, so it becomes like more centralized. With proof of work, you need to sell coins, the miners need to sell coins to subsidize and pay for the electricity bill. So it ends up being more like the owners of the Ethereum would be more people, so more decentralized, and switching to proof of stake is a more fair distribution of the coins, which I don't think it was something that people thought about when they decided to go to proof of work first, but it's a really good side effect of this transition.
Yeah, it was a lot of, certainly anyone with a video card rather than anyone able to buy Ethereum, especially at the time, buying in 2015, it was fairly difficult to actually buy cryptocurrencies for most people. So getting started in the industry with a video card was a lot lower barrier of entry and created a more decentralized network. But yeah, I don't think that was an intentional situation, but it was certainly a benefit.
So we have the answer from the chat. They say A and C. It's interesting that the censorship resistance is not there, even though. So the answer, let's just move to the answers. So it's A, B, and C. And so it's really good that someone said A and C, because like the recent discussions on like Tornado Cash and like staking and all other aspects, it is still censorship resistance, like application layer that is not basically living to this promise. Like DeFi is kind of like it's fractured right now and like trying to like figure out going through the identity crisis. But the censorship resistance on the base layer and Ethereum layer and like mining and staking still is true, in my opinion.
I think it's important to note that really all of these points are gradients and the spectrum. So, something isn't necessarily open or closed so much as a spectrum of that. And Ethereum's certainly fairly open. Censorship resistance, though, it's I think describing it as a gradient is extremely appropriate, and sometimes there's the needle unfortunately goes backwards in one direction and the other, and we're kind of seeing that right now. But that's always learning experience.
The spectrum's an interesting point. Somebody put in the chat about how it'll be more decentralized, or starting with proof of work allowed the world to mine ETH, and that would be more decentralized. So everything is on a spectrum with how decentralized something is. The second there are more nodes, it's more decentralized. It's like it goes back and forth either way with a lot of different things. It's only as open as people that have access to the internet, right? If you don't have access to the internet, it isn't open to you until you get that access. So I like that you brought that up, Josh, with that spectrum or gradient. Okay, so let's go to the next question. And after I read this and we do the answer, I'm not going to go into a big explanation because the next question is connected to it. And I think it'll be easier to explain it as a whole. So we'll start with this and then the next one afterwards. All right, question 14. Miners will still need to do proof of work algorithms after the merge. True, false, or only if their mom tells them to? Which, I mean, I always joke that one of the things that I really want to happen with mass adoption is for my mom to finally understand that what I'm doing is like not a like behind the scenes criminal act, like that she actually sees crypto for what I see it as. And like when I visit her, she'll stop putting like articles across the breakfast table, you know, like sliding it across, like, well, have you heard about this? And I'm like, oh my God, Mom. So like fingers crossed that that'll stop. Okay, so let's do the answer and then we'll get into the next one and do like an overall explanation of it. So I'm not sure if anyone has written in the book or in the YouTube yet. So, okay, let's do the answer. Oh, you already did it. Is false. I was distracted because real quick, somebody asked in the chat if we have a CEP prep book coming out soon, and we are finalizing it now. It has mostly been written. We're 94% of the way done with the writing of it. And we're just going through and finishing that up and doing drafts and then making sure we have some testers that don't know much about Ethereum, read the book, take the exam to see if they pass. And if they do, then the book is good to go and we will be releasing it, but it will definitely be available by DevCon. So mid-October or sooner. All right, let's get into the last question, then we can explain these two together.
You want to do, yeah, because two people answered true, and I want to explain, but I guess we can do.
Well, if you want to explain now leading into the next one, I just know they're very closely connected.
In this case, we're talking about the miners that are mining proof of work algorithm on Ethereum. What would they do after the merge on Ethereum? Which is, there won't be any more proof of work on Ethereum, it will be proof of stake. But I guess now we can just go to the next question, which is our last question here, and then we can discuss this further because I think it's the topic of the day. Just saw, is this like that's a dimension here. So what will happen to the proof of work chain after the merge? A proof of work chain will shut down on the first day of the merge to proof of stake. B, the proof of chain will become a shard of the proof of stake chain. C, proof of work chain will become Ethereum Classic 2.0. And D, it will open a portal to another dimension. And one thing I want to add, so these questions are part of like CEP exam. And I believe this question, we basically made this question around, like we created this question around a year ago. We edited some of the terminology there, saying the merge around maybe a few months ago. So every discussion that is happening last week on Twitter has not impacted us on coming up with this question. Yeah, so I'm going to give a few minutes or a few seconds for anyone that wants to answer.
Man, we're so prescient.
Everyone is really excited in the chat about the prep book, which I'm excited about because I want to help us with testing it. So yay. If you're in the chat asking about it, please read it, what I wrote, and then send us an email so that we can get you on the list to help us with that. So thank you for being interested. I love it.
And you're probably also very excited about the portal to another dimension.
I mean, duh.
Yeah.
So we have one answer, C, since the merge is about proof of work chain moving to the beacon chain, so there is only one chain going forward. And the answer maybe C, maybe A. And the answer is C. So that's kind of like everyone's saying. But so that's why. So we have C, which is SE is the user, saying B is the option. So this is why the discussion the last while on Twitter about like proof of work or ETH proof of work is kind of related here. So the idea of proof of a stake is that we had beacon chain as like one just beacon of life, as one say, or like just a rhythm for the last 2 years to test everything, to get enough people doing staking, proof of stake. So it's tested and we know that it works. Basically, it doesn't do anything. It just produces empty blocks. And by the time that merge comes, which would be around September 15th or 14th, it should be ready to merge the proof of work and all the transactions around it into beacon chain. So they call it consensus layer, which would be the beacon chain or proof of stake, and execution layer, which is the get or all the transactions and that happening into the merge. So it becomes one shard of the proof of stake chain, which later on we'll have, I think, up to like 64 shards, but that's like almost in a year. Like there's like a bunch of updates should happen to get there. Now, the reason like I think everyone's at sea is because all these controversial conversations about proof of work chain, and something that a lot of people say, like thinking recently about, oh, miners can just fork the network. It's been always on the radar. Like when you think about it, miners have this hardware, basically they can continue using proof of work. But one of the things about Ethereum is the difficulty bomb that has been there since day one. And it's about pushing change. Like you basically remove the, you cannot make any decisions by inaction. You have to take an action, change something. And one of the changes that they did in proof of work fork that I've seen on Twitter, there's a bunch of different ones, but the main one they're talking about, it's almost borderline scam, because like a few of the changes, one is all the ETH deposited in a smart contract of the ETH to smart contract, because it's one contract for staking, would just be going to ETH POW smart contract or multi-sig, just like changing the balance of that. The other one is like everything with EIP 1559, we said like parent Ethereum would go directly to their multi-sig. And these are the changes that are changing the whole fundamental of the token economy, how the incentive models work. And I'm not a believer in that. I knew it's going to happen. There's going to be more forks of that, similar to what when Ethereum Classic, like the changes with Ethereum Classic is Ethereum Classic was ideological. There was no financials around it. Like there was that blockchain should not change, should be immutable. And with Bitcoin, we've seen like Bitcoin Cash, Bitcoin Gold, Bitcoin ABC, maybe all these other forks. I think at some point there was 42 forks of Bitcoin going on at the same time. Just one thing I say to everyone, make sure you don't go with your greed or like just taking some free money out of there, because there is no necessary replay protection, meaning that if you send a transaction on one chain, it's highly possible that someone can replay the same transaction on the other chain. So my advice is not to react right away after any of these forks, and just see what happens. If you're in this for the long game, if you're trading or just want to play, like make some money every day, it's your call. It's a long game, just be patient.
Before you jump in, Josh, before you jump in, we can keep talking about this. If anyone on the stream needs to go, please feel free to hop off, but we can continue this discussion for now. Just want to put that out there. Go ahead, Josh.
I was just going to say, if you can, on the day of the merge and maybe a day afterwards, just take the day off from transactions. Let things settle a bit. If you if there's things you expect you'll need to be able to do, maybe do them a day or two before things actually take place. Especially that main day, there might be a lot of chaos in understanding, which clients you should be using, understanding if the services that you use are following the chain properly and everything's in place and working properly. Now, of course, there could be lots of fun to be had on that day as well. So don't let me completely suggest that you shouldn't be involved in things. But if you're more concerned about your funds and wondering what you should do, I honestly think the best thing to do on that day is probably nothing at all.
Yeah, one analogy is talking about like this merge. First of all, the merge happens within 15 seconds. It's not like it's going to be longer, but there's side effects, a lot of things around it. There is supposed to be no reorgs, but it really depends on how many nodes in the network are updated. There is so many things involving here. But the analogy is usually like saying changing the engine on a flying airplane. Like that's kind of like that with all the 5 clients, all these networks. So to extend on that analogy, don't order hot beverages while there is like a change engine being changed on your airplane. So that's kind of like what I would say. But yeah, it's exciting, but also it's Wild West. So we'll see.
I mean, I feel like nothing comes without some type of risk that's worth doing. That's just like the way of the world. Are there going to be launch parties happening?
Probably like online, yeah.
Yeah.
I don't know
or
about that
like,
many,
should
but
we
if
have
you,
one?
yeah, you can. There's going to be awkward dev calls, most probably similar to like the merge on Gorley or testnets that everyone was on the call. So similar things probably is going to happen.
Yeah, and if you don't follow Hannah on Twitter, she's super funny. Hannah, I loved your Shania Twain merge Twitter GIF. I thought that was hilarious. Let's go, girly.
Hey, thanks.
Girls, girly. I thought that was cute.
I think
all right.
it's happening around all of the Berlin events too. So if you happen to be in that area at that time, you might want to take a look at those.
Yeah, that sounds fun. Okay, we are out of time, but I did want to say before we go that if you've watched this and you've watched it to the end, we would love for you to sign up to take the Certified Ethereum Professional exam. You don't need to take it right after you sign up for it. You can enroll and then wait until you feel ready for it, whether that's when the prep book is out or you've had more time to study, whatever that looks like for you. The coupon code is CEP free. So feel free to get on, enroll, and just hold off and wait until you're ready, or find out if you're ready now. We're excited that you're interested in learning more about Ethereum and becoming CEPs. So thanks for joining today. And I put couple links in the chat for our 2 previous sessions that are all about the merge. So if you're interested in what we were talking about towards the end and want to hear more about it, please check those out and you'll learn a lot of what you need to know to understand what we were talking about in more detail. So thank you all for joining. I really appreciate our CEP committee. We could not do this without you. And we will be back next month for another live stream.
Thank you.
Ciao.
Thank you all.
Have a good